Okay, so this is number 6. We are verifying trigonometric identities. Okay, so we can either make the left side look like the right or the right side look like the left. A good rule of thumb is try to go for the one that is a one monomial piece. Like this is one piece right here, and these are two pieces because they're separated with addition and or subtraction. So I'm going to make the two pieces basically look like the one piece. Just like over here, we have two pieces and we have one. So I'm going to make this right side look like the left side. Okay? Now you can do either one on the test. That's just the one that I would most likely refer to you as far as to suggest your approach. Alright, so verifying identities. What we're trying to do is make everything cosine and sine. So let's go ahead and start. So cosine of x over sine of x is the same as cotangent. And then we have and then tangents, trigonometric ratio is sine of x over cosine x. Now keep in mind, we are trying to make it look like this right side. So this right side is just going to copy over until you finally get it to look like secant x, cosecant x. Then you would be done here at this step. So let's go ahead and get it to that spot. So I'm adding fractions, and a good rule of thumb to add fractions is to get a common denominator. So I'm going to multiply this by a form of 1, because that's what this one had that this one didn't. And I'm going to do the same to the right one. I'm going to multiply this one here by a form of 1, which is sine of x over sine of x. Okay? So now my denominators are common. They're both cosine sine. So that means we're going to multiply the top, so we get cosine squared. We're going to multiply this top and get sine squared. And now we're able to bring it all together in addition, because of this, under one complete common denominator. We know from our trig identities that this cosine squared plus sine squared is the same as 1. And we see that right here as far as what we highlighted in class. So sine squared plus cosine squared is 1. So we're going to come back here and just write 1 over cosine sine. Now this is the same as if we were to break it up into two, like 1 over cosine and 1 over sine. And we know that 1 over cosine is the same as secant. And we know that an understood 1 here over sine is the same as cosecant. And now we have our left that looks like our right. So you could put equals, 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 and all of this work is pretty much the pieces that you will get credit for on the test. Alright, so now we're going to make the right side look like the left. So let's just put an arrow down saying that we're going to end up looking like this, and with sine of theta. And it's going to equal the manipulation that we're going to do on the right side as far as getting it to look like the left. Alright, so cosecant is 1 over sine, and sine is just sine over 1. And since I am, just like the other one, subtracting fractions, I need a common denominator. So let's multiply them so that they're common as far as their denominators go. So the only thing that I have to multiply here is the second term by a form of 1, which is sine theta over sine theta. Now I have my, I'll do it in green, my denominators are now common. So I can bring it under one huge fraction of sine of theta, and now on the top right, this becomes sine squared, which I'm going to subtract from 1. Alright, so let's go ahead and write sine squared. Now back to the identities formula chart, we did have that same identity that if we do manipulate it, and let's say that I'm going to move cosine to the right side, I would have sine squared x is equal to 1 minus cosine squared. Okay, so all I did was subtract this over to the right side, so that now whenever I see 1 minus cosine, I can substitute it with sine squared. Okay, and vice versa. This one is 1 minus sine squared. So if I were to move the sine squared over, we go ahead and move that over, means subtracting this, subtracting this sine squared over to the right. I would be left with cosine squared on the left, and then that 1 minus sine squared on the right. So anywhere where I see 1 minus sine squared, I can substitute for cosine squared. So I'm going to substitute the top with a cosine squared, and now the bottom will remain this sine squared that didn't change. And now if you were just to copy it, you have cosine squared over sine, which is now the left and the right side look the same. So that's how you verify the identities.